everyone. Welcome to LAPPconnected. I'm Jürgen, Product Manager here at LAPP, and we are excited to have you join us for the second episode, Unmanaged Switches. And with me today is our expert and application engineer for industrial communication, Thomas Leitmann. Hi Thomas, it's great to have you here.
Hi Jürgen. We'll cover the basic functionalities and the most important features. And we will explain you how to recognize high-quality switches.
Thomas, let's talk about data per port. Will be the mentioned data rate split it into the number of ports?
The specified data rate is available at each single port and in both directions, since we normally have full duplex communication. The maximum data rate is specified by the lowest data rate of the connected devices. So when you connect a 100 megabit device to a 1 gigabit switch port, the data rate is set to 100 megabit. This is done automatically.
Let's switch over to memory size of switches. I have found several numbers like MAC address table and packet buffer. Some manufacturers even don't mention these. What is MAC address table about and what's its benefit for users?
In Ethernet communications, not only the IP addresses are used, but also MAC addresses. A switch has to know at which port the devices are. And as soon as a telegram comes from the device, it knows where it is. When it doesn't know, it floods the telegrams to all ports. If it knows it, then it enters it, it stores it in the MAC address table, and the next time a telegram is sent, it is only sent out to this single port. The MAC address table not only contains the addresses of the devices which are directly connected to the switch, but also of all other devices which are behind them. When the MAC address table is full, the switch starts flooding again. So a larger MAC address table size can reduce network traffic.
Another number I saw is the packet buffer. What is this figure about?
When there are lots of telegrams coming in from several ports, which exceed the maximum data rate, then these telegrams are stored in the packet buffer to be sent out later to the port when they are free capacities. When the packet buffer is full, you get telegram discards. So a larger size of the packet buffer can reduce the risk of telegram discards.
Let's take a look at the powering options of unmanaged switches, as there is redundancy as an example and AC options. What are these options about and can you briefly explain these?
A switch normally works as long as the power supply is okay. When the power supply fails, the switch also fails. With a redundant power supply option, the switch is connected to two independent power supplies. So when one of the two fails, the switch still works. Regarding AC-DC power, you normally have either 230 volt AC or 24 volt DC. A switch which can be driven also by 24 volt AC can use only a simple transformer instead of a real power supply for 20 volt DC.
Another topic is statistics quality numbers. I found several values and as an example the MTBF. What does this mean to us?
MTBF means mean time before failure. This number is a statistical value which gives a hint to the lifetime of your product. It's also a name of the quality of your components. So the higher the MTBF value, the higher the device and the component quality.
Another topic is availability. We have talked about product quality. But how about network availability? Here I found broadcast storm protection as an example. Why can that be important in running a network?
Unicasts are sent to only one device. Broadcasts and multicasts are sent to several devices. On a network error, for example, on plugging in a ring or a misconfiguration, this can lead to lots of broadcasts, which can congest your network. The broadcast storm protection feature filters out such telegrams and increases the availability of your network.
A big thank you to you, Thomas. And to never miss the latest video, subscribe to our channel